The James Webb Space Telescope, JWST, has recently unveiled a series of findings that are both awe-inspiring and deeply perplexing, shaking the foundations of modern cosmology. These revelations suggest that our current understanding of how the universe formed and evolved may be significantly flawed or incomplete. What was once thought to be a quiet, uneventful early universe has now been revealed as a place full of complex, well-structured galaxies, some of which are eerily similar to our own Milky Way, despite having formed extremely early in cosmic history. According to long-standing models of cosmology, the early universe should have been a chaotic and underdeveloped place, lacking the kind of large-scale structure that defines galaxies today. The prevailing theory suggests that following the Big Bang, it took hundreds of millions of years for the first stars and galaxies to form. However, observations made by the James Webb Space Telescope are contradicting this narrative. Instead of an infant universe slowly evolving, JWST has revealed a cosmos already populated with mature, massive galaxies within the first billion. Years after the Big Bang, one of the most significant and puzzling discoveries involves galaxies that appear as mirror images of our own. These galaxies not only resemble the Milky Way in shape and size, but also in structure, with defined spiral, arms, central bulges, and star-forming disks. Such formations, according to current models, should require billions of years of slow hierarchical growth, where smaller structures merge and coalesce into larger ones over time. Yet these galaxies, spotted when the universe was less than a billion years old, already display the characteristics of well-formed spiral galaxies. The implications are profound. If galaxies with mature spiral structures existed this early, it calls into question the timeline and mechanisms of galaxy formation. One particularly notable discovery is a galaxy named Long, recently identified by the JWST. This galaxy is being hailed as the oldest spiral galaxy ever discovered. It existed when the universe was just about 1 billion years old, a mere blink in the grand scale of cosmic time. What's truly extraordinary is that Long closely resembles the Milky Way in both structure and mass. It spans roughly 60,000 light-years and contains around 100 billion solar masses of material, compared to the Milky Way's approximate 100,000 light-year width and 1.5 trillion solar masses. Dr. Muan Xiao, a postdoctoral researcher at the University of Geneva and the lead author on the study, emphasized the astonishing similarity. He explained that while Long is older than our galaxy, it could easily be mistaken for a sibling due to its striking resemblance. It possesses a central bulge filled with older stars, a disk where new stars are actively forming, and well-defined spiral arms. This is not only highly unusual for such an early galaxy, it's nearly unthinkable according to standard cosmological models, and Long is not alone. Several other early universe spiral galaxies have been spotted, each more baffling than the last. One such example is Sears 2112, a galaxy located about 11.7 billion light-years away. Even at that distance, and thus seen as it was when the universe was extremely young, it already shows a well-defined spiral shape. This suggests that the formation of galaxies, particularly those with complex structures, may have occurred far earlier and far more rapidly than previously thought. Another recent JWST discovery involves a galaxy that resembles a massive wheel, again, showing surprising maturity for its cosmic age. The existence of such galaxies in the early universe is becoming increasingly difficult to dismiss as anomalies. Instead, it appears that the early cosmos may have been far more productive and organized than our models have anticipated. This accumulation of spiral galaxies, so early in cosmic time, directly challenges the foundation of hierarchical galaxy formation theory. Adding to the mystery, JWST has detected galaxies at extremely high redshift values, greater than 15 and possibly even approaching 20. Redshift is a measure of how much the light from a distant object has been stretched due to the expansion of the universe. Higher redshift values correspond to greater distances and earlier times in the universe's history. A redshift of 1520 means we are observing galaxies as they were just 100 million years after the Big Bang, a period when the universe was still in its earliest stages. In a recent analysis, astronomers selected 10 promising candidates from JWST's Deep Sky Survey. These objects possess colors and spectral properties, suggesting they lie at redshifts between 15 and 20. If these findings are confirmed, they would represent the earliest galaxies ever observed, formed only a few million years after the universe itself began. This would significantly compress the timeline for galaxy formation and demand a re-evaluation of our theories. Some scientists are understandably skeptical. The idea that galaxies could form so quickly and in such an orderly fashion goes against decades of accumulated theory and observation. As a result, researchers are calling for detailed spectroscopic studies to confirm the true distances and ages of these galaxies. However, if confirmed, these discoveries would force a radical shift in how we understand the early universe. Even more intriguing, among these early objects are 3 that may not be galaxies at all, but something far more exotic, so-called dark stars. Astronomers Cosmin Lee, Gillian Payne and Catherine Fries have suggested that some of the objects identified might be early stars powered not by nuclear fusion, like modern stars, but by dark matter. These theoretical dark stars would have formed around 200 million years after the Big Bang and would shine not because of traditional fusion, but due to dark matter particles annihilating at their cores. This is an entirely new class of stellar object that, if real, could open up an entirely new field of astrophysics. Another key revelation from the James Webb telescope relates to the expansion of the universe itself. The data now suggests that the rate of cosmic expansion in the early universe does not match the rate we observe in the nearby universe. This discrepancy, known as the Hubble tension or cosmic tension, has been a topic of growing concern among cosmologists. If the universe is expanding at different rates in different epochs or directions, it may imply that our understanding of time, space, and cosmological distance is fundamentally flawed. One of the most startling implications is the idea that the universe might not have a fixed age. If expansion rates differ depending on when and where you're observing, it raises the possibility that some regions of the cosmos could be older or younger than others. This goes against the long-held assumption that the universe is isotropic and homogeneous, uniform in all directions, and consistent in structure and age. All of these findings, from ancient spiral galaxies to inconsistencies in the universe's expansion, are forcing cosmologists to consider bold new theories. Some scientists, such as Nobel laureate Roger Penrose, have proposed that our universe may have emerged from a previous one in a repeating cosmic cycle. Others speculate about the existence of a mirror universe that coexisted with or even preceded our own. Still more radical theories suggest that the universe might not have had a beginning at all and has existed in some form eternally. There are also hypotheses that question the very nature of cosmic expansion. Perhaps what we interpret as expansion is merely a distortion of space-time, or perhaps dark matter and dark energy, 2 of the most mysterious components of the universe, don't exist in the way we currently believe. These are not fringe ideas anymore. They are being seriously considered by reputable scientists because the data demands new explanations. The James Webb Space Telescope has not just expanded our view of the cosmos, it has disrupted it. It is showing us a universe that is older, more complex and more organized at earlier stages than we ever thought possible. Rather than confirming existing theories, JWST is challenging them, opening the door to a new era of cosmology. The early universe was supposed to be a dark, quiet place. Instead, it was alive with galaxies, many of them strikingly familiar. As we continue to analyze data from JWST, we may need to completely rethink how the cosmos came to be. The question is no longer simply when the first galaxies formed, but how they formed so quickly, and why they look so much like the structures we see around us today. These are questions with no easy answers, but they represent the next frontier in our quest to understand the universe.